ever think about what happens after a brand new medicine gets approved? How do we really know it's safe for millions of different people, not just the few hundred who were in that initial clinical trial? Well, today we're pulling back the curtain on something called prescription event monitoring. It's this hidden safety net that's working in the background to protect all of us. Okay, let's dive right in. Seriously, think about it. This is a question that affects pretty much every single one of us. When you or someone you love starts a new medication, you're putting a massive amount of trust in its safety. But how can we be so sure, right? Especially when the very first tests only look at a small and often very specific group of people. This right here, this is the critical gap that prescription event monitoring was invented to fill. The thing is, every clinical trial has what you could call a blind spot. Now, don't get me wrong, clinical trials are absolutely essential. They're the non-negotiable first step, but they just can't predict every little thing that might happen when a drug is used by a massive, diverse population over a really long time. And that's where getting real-world data becomes so incredibly important. And this slide just lays it out perfectly. Look at the left side. That's the super controlled world of a clinical trial. You've got a limited number of people, maybe a few thousand if you're lucky, and it's usually just for a few weeks or months. But then you flip over to the right column, and that's the real world. Suddenly we're talking about millions of people, all different ages with all sorts of other health conditions, taking the drug for years. This is where those super rare or slow to develop side effects finally have a chance to show up, the ones that were basically impossible to find in a small, short-term study. So what do? How do we possibly bridge that huge safety gap? Well, you need a real-world safety net. And that's exactly what prescription event monitoring, or PEM, is. It's the system designed to keep an eye on a medicine long after it gets that initial green light. So what is PEM, really? At its core, it's all about one thing: observation. Researchers don't step in, they don't tell doctors what to prescribe or patients what to do. They simply watch and learn as regular people use new medicines in their normal, everyday lives. It gives us this true, totally unfiltered picture of how a drug actually behaves out in the wild. And the whole mission of PEM is to find those needles in the haystack. It's designed to hunt for those incredibly rare side effects that clinical trials are almost guaranteed to miss. The kind of thing that might only pop up in one person out of every 10,000. It's our best tool for keeping a constant watch on a drug's safety and, in doing so, protecting millions of patients. Okay, so how does a system like this actually work? How do you track a medicine's effects across an entire country? It sounds kind of complicated, right? Well, let's break down the process. And we'll use the pioneering model from the UK's Drug Safety Research Unit as our guide. So the engine that drives this entire system is a pretty simple but incredibly powerful tool called the Green Form. This is a questionnaire that gets sent to doctors, and its secret sauce lies in one single instruction: report every single medical event a patient has after starting the new drug, whether it seems related or not. A sudden headache? Write it down. A case of the flu? Yep, that goes on the form too. This way of collecting data without making any assumptions is what allows researchers to spot hidden patterns that everyone else would have missed. So here's how that green form fits into the whole puzzle. First, a new drug gets chosen for monitoring. Then, as you see in step 2, every single prescription for that drug is tracked across the country. After a little while, those super important green forms get sent out. Once doctors send them back, all that patient data is collected and popped into a huge, secure database. And finally, step 5, this is where the real detective work begins. Analysts start combing through the data, looking for any unusual patterns or safety signals that might need a closer look. It's this continuous loop of information that helps keep our medicines safe. All right, now let's be real, no system is perfect, and PEM is no exception. It has some incredible strengths, things it does better than anything else, but it also has some key weaknesses. So let's take a balanced look at both sides of the coin, starting with the good stuff. Okay, the strengths of PEM are huge. First off, its national coverage gives us this massive, diverse sample size that clinical trials can only dream of. It's also amazing at catching delayed reactions. For example, a new arthritis drug might seem totally fine for 6 months, but PEM could be the thing that reveals a strange pattern of rare liver issues that only start showing up after a year of use. It's built to find that kind of long-term signal. Plus, it gives us absolutely vital data for vulnerable groups, like tracking pregnancy outcomes to make sure medicines are safe for expectant mothers. But on the flip side, there are some real-world challenges. For one, PEM can't know for sure if a patient is actually taking their medicine correctly, or even at all. It also has a big blind spot for anything that happens entirely inside a hospital. But maybe the biggest hurdle is that the whole system is only as good as the data it gets. It completely relies on busy doctors taking the time to fill out and send back those green forms. And these are definitely important limitations to keep in mind. So, when you weigh the pros and the cons, what's the bottom line? Why is this imperfect, sometimes complicated system just so incredibly important for our health? Let's zoom out and take a look at the big picture. It really all comes down to this. PEM is like our silent guardian in public health. It works tirelessly behind the scenes to make our medicine safer. Now, it's not a perfect system, but it is an absolutely essential layer of protection that bridges that potentially dangerous gap between the sterile, controlled world of clinical trials and the messy, complex reality of everyday life. And all of this leaves us with a really fascinating question for the future, doesn't it? As medicine gets more and more personalized and our treatments get way more complex, how will our safety nets need to change and evolve? What does the next generation of drug monitoring even look like? Well, that's the big challenge that researchers are tackling right now, building on the incredible legacy of systems like PEM. It's a fascinating space to watch. Thanks so much for joining me.